Welcome to this model. In this model, we are going to see about the fundamentals and link layers. Now, let us see about data communications. Data communications and networking are changing the way we do business and the way we live. And business decisions have to be made ever more quickly, and the decision makers require immediate access to accurate information. So, when we communicate, we are sharing information, and this sharing can be local or remote. Between individuals, local communications usually occurs face to face, while remote communications take place over distance. The term telecommunication, which include telephony, telegraphy, and television, means a communication at a distance. And the word data refers to the information presented in whatever whatever exchange of data between two devices or some form of information medium like wire or cable. And for data communication to occur, the communicating devices must be a part of a communication system made up of a combination of hardware and software. The effectiveness of a data communication system depends on four fundamental characteristics: delivery, accuracy, timeliness, and jitter. Delivery. The system must deliver data to correct destination. Data must be received by the intended device or user and only by the device or user. And accuracy is nothing but the system must deliver the data accurately. Data that have been altered in transmission and left uncorrected or unstable. Timeliness is the system must deliver data in a timely manner. Data delivered late or useless. In the case of video and audio, timely delivery means delivering data as they are produced in the same order that they are produced and without significant delay. It should be delivered, right? So this kind of delivery is called real-time transmission. Jitter is nothing but it refers to the variation in the packet arrival time. It is the uneven delay in the delivery of audio or video packets. For example, let us assume that the video packets are sent every 30 milliseconds. If some of the packets arrive with 30 millisecond delay and others with 40 millisecond delay, an uneven quality in the video will be the result. And now let us see the components of a data communication system. The data communication system has 5 major components. One is message, sender, receiver, transmission medium, and protocol. The message is the information to be communicated. Popular forms of information include text, numbers, pictures, audio, and video. The sender is the device that sends the data message. It can be a computer, workstation, telephone handset, video camera, and so on. And the receiver is the device that receives the message. It can be a computer, workstation, telephone handset, television, and so on. And transmission medium is the physical path by which a message travels from a sender to receiver. Some examples of transmission media include twisted pair, wire, coaxial cable, fiber optic cable, and radio waves. A protocol is a set of rules that govern data communication. It represents the agreement between the communicating devices. Without a protocol, two devices may be connected but not communicating, just as a person speaking in French cannot understood by a person who speaks in Japanese. Now, let us see some of the data representation. Information today comes in different forms such as text, numbers, images, audio, and video. In data communication, text is represented as a bit pattern, a sequence of bits that is zeros or ones. Different sets of bit patterns have been assigned to represent text symbols. Each set is called a code, and the process of representing the symbols is called coding. And today, the prevalent coding system is called Unicode, which uses 32 bits to represent symbol or character used in any language in the world. The American Standard Code for Information Interchange, developed some decades ago in the United States, now constitutes the first 127 characters in Unicode and is also referred to as Basic Latin. And numbers. Numbers are also represented by bit patterns. However, a code such as ASCII is not used to represent numbers. The number is directly converted to a binary number to simplify mathematical operations. Images. Images are also represented by bit patterns. In its simplest form, an image is composed of a matrix of pixels where each pixel is a small dot. The size of the pixel depends upon the resolution. For example, an image can be divided into 1000 pixels or 10,000 pixels. In the second case, there is a better representation of the image, but more memory is needed to store the image. After an image is divided into pixels, each pixel is assigned a bit pattern. The size and the value of the pattern depends on the image. For an image made of only black and white dots, a 1-bit pattern is enough to represent a pixel. If an image is not made of pure white and pure black pixels, we can increase the size of the bit pattern to include grayscale. For example, to show 4 levels of grayscale, we can use 2-bit patterns. A black pixel can be represented by 00, a dark gray pixel by 01, a light gray pixel by 10, and white pixel by 11. There are several methods to represent color images. One method is called RGB, so called because each color is made of a combination of 3 primary colors called red, green, and blue. The intensity of each color is measured and a bit pattern is assigned to it. Another method called TCM, this is in which a color is made of a combination of 3 other primary colors called yellow, cyan, and magenta. That is YCM. Right. And the next form of data representation is audio form. Audio refers to the recording and broadcasting of a sound or music. Audio is by nature different from text, number, and images. It is continuous, not discrete. Even when we use a microphone to change voice or music to an electrical signal, we create a continuous signal. And video refers to the recording or broadcasting of a picture or movie. Video can either be produced as a continuous entity, that is by, for example, by a TV camera, or it can be a combination of images such as discrete entity arranged to convey the idea of the motion. Again, we can change a video to a digital or analog signal. Now, let us look into data flow. Communication between two devices can be simplex, half duplex, or full duplex. As you can see in this diagram, in simplex mode, the communication is unidirectional as a one-way street. Only the one of two devices on a link can transmit and the other can only receive. Keyboards and traditional monitors are examples of simplex devices. The keyboard can only introduce input and the monitor can only accept output. The simplex mode can use the entire capacity of the channel to send data in one direction. Next is half duplex. In half duplex mode, each station can both transmit and receive, but not at the same time. When one device is sending, the other can only receive, or vice versa. The half duplex mode is like a one-lane road with the traffic allowed in both directions. When cars are traveling in one direction, car going the other way must wait, and in half duplex transmission, the entire capacity of the channel is taken over by whichever of two devices is transmitting at the same time. Walkie-talkies and CB are both half duplex systems. The half duplex mode is used in case where there is no need for communication in both directions at the same time and the entire capacity of the channel can be utilized for each direction. In full duplex, so-called duplex, and both stations can transmit and receive simultaneously. The full duplex mode is like a two-way street with the traffic flowing in both directions at the same time. In full duplex mode, signal going in one direction share the capacity of the link with the signals going in the other direction. This sharing can occur in two ways. Either the link must contain two physically separate transmission paths, one for sending and the other for receiving, or the capacity of the channel is divided between the signals traveling in both directions. One common example of full duplex transmission is the telephone network. When two people are communicating by a telephone line, both can talk and listen at the same time. The full duplex mode is used when communication is in both directions is required at all the time. The capacity of the channel, however, must be divided between two directions. Now, let's move on to networks. A network is a set of devices connected by communication line. A node can be a computer, a printer, or any other device capable of sending or receiving data generated by other nodes of networks. Distributed processing is nothing but most networks use distributed processing only, in which the task is divided among multiple computers. Instead of one single large machine being responsible for all aspects of a process, separate computers handle a subset. And network criteria is nothing but if a network must be able to meet a certain number of criteria. The most important of these network criteria are performance, reliability, and security. The performance can be measured in many ways, including transit time and response time. Transit time is the amount of time required for a message to travel from one device to another. Response time is the elapsed time between the inquiry and the response. The performance of the network depends on the number of factors, including the number of users, the type of transmission medium, the capabilities of the connected hardware, and the efficiency of the hardware. Performance is often evaluated by two networking matrices, throughput and delay. We often need more throughput and less delay. However, these two criteria are often contradictory. If we try to send more data to the network, we may increase the throughput, but we increase the delay because of traffic congestion in the network. In addition to the accuracy and delivery, network reliability is measured by the frequency of failure, the time it takes a link to recover from a failure, and the network robustness in a catastrophe. And network security issues include processing the data from unauthorized access, protecting data from damage and development, implementing policies and procedure for recovery from breaches and data losses. Thank you.